Hello everyone, today we are going to talk about Kruskal's algorithm for the minimal spanning tree. So what is a minimal spanning tree? Minimal spanning tree is like a tree which is created from like a graph, from a subgraph of a graph. And this subgraph contains all the vertices of the graph, and all these vertices are connected. It means to say that there is a path between them, and it's also important to note that these paths do not form a cycle. So now let's see, why do we need minimal spanning tree? Minimal spanning trees have a wide range of applications, like designing the networks in short range, like such as local area network. We need in the minimal spanning tree in order to design local area networks, and also for laying down the pipes line system for refineries, sewage system, and water transport if needed. So for all these, we are going to need the minimal spanning tree. So let's see how Kruskal's algorithm uses greedy techniques in order to get the minimal spanning tree. So first, let us take a sample graph. Right. Um, I'll just draw it like this. So I'll name it as A, B, C, D. Now this makes one small correction. Okay. A, B, C, D, and E. And let the edge weights be like 1, 2, 5, 4, and 3. So now we have got the graph. Now, what do we do in Kruskal's algorithm? So in Kruskal's algorithm, basically, first we take the edge weights with the least weight, and then we build it from there. So basically, DA has the least weight. First, we're going to put that, and then AE and BC have the next least weights. So, and we're going to build it using that, then, and so on. So let's see how we're going to do it. So BA has the least weight. Let me draw that. Next, EA has the least weight. Let me draw that. And CB has the least weight. EA and CB has the least weight. There is no specific order in which you have to pick it, but do make sure that when you do this, make sure that there is no cycle exists in your paths. Oh, yeah, wrong one, and yeah, BC. And then the next one with the least weight is EC. So that's like, let me just name the nodes, and A, B, C, with the edge weights 1, 2, 3, 2. So now we clearly see that we have got then the minimal spanning tree with the minimum edge weights that are required to travel through each nodes. So now there's another algorithm other than Kruskal's algorithm, which is called the Prim's algorithm. The Prim's algorithm is same such as this, but Kruskal's algorithm is much more easier in the fact that it's much more easier to implement. We could easily find the minimal edge weight using some sorting programs, and we could easily implement this. And the next one is also the time complexity. The time complexity of Kruskal's algorithm is big O of n, while the time complex, where n is the number of vertices, of course, where the time complexity of the Prim's algorithm is big O of n cross E, where n is the number of vertices and E is the number of edges. As you can clearly see, Kruskal's algorithm is far superior to Prim's algorithm. So that's all from my seminar topic. I hope you enjoyed this, and I hope to see you next time.